Hey guys, it's Athena. I'm going to go ahead and show you how to do a relatively simple, Taylor series. But first I'm going to talk about Taylor series a little bit before we get to this question right here. Taylor series is usually written as infinity over sigma over n equals 1 or 0, with the expression next to it being f to the n times x minus a to the n over n factorial. However, I like to spread it out a little to make it make a little bit more sense to me, and it would look something like this. This here, our f to the a, would be our f to the 0th derivative, if that makes any sense. So it would be just a coefficient. This would be our first derivative, so this right here would be over 1, and this is to the first power. When we start getting into our second derivative, it would be our second derivative answer to the a over 2 factorial, so it would be 2 times 1, with x minus a squared. Our third derivative would be over 3 factorial with x minus a to the third. And if we were to take a fourth derivative or a fifth derivative, it'd be over 4 or 5 factorial to the fourth or fifth power. Let's go ahead and get to this question now. We want to start out with the concept that f of x is equal to f of a, which makes, sense. We can just go ahead and substitute a for x. So when we do that, we get this, and I just went ahead and put 0 plus 1, substituting 0 as a for x, to the 1/2, which is the same as square root, and when we condense that into math, that equals 1. Okay, now we're going to take the second derivative, as our trend suggests. And again, if f of x is equal to f of a, f prime of x should equal f prime of a. So the first derivative is 1/2 x plus 1 to the negative 1/2. So there's our first derivative. And what we're going to do is substitute our a for x. So we plug in our 0 value. And when we condense that down, again, we get 1/2. Okay, since 2 points don't make a trend, we're going to take another derivative. And this is our second derivative. Our second derivative is negative 1/4 x plus 1 to the negative 3/2. And that's just using, simple derivative rules to figure out this math. Again, we're going to substitute our 0, our a, into the equation. And again, we're going to condense that down, and we get negative 1/4. That's our answer. Okay, now, you may say 3 points constitute a trend, but since our first one here is just going to be a coefficient, like I showed you earlier, we're going to go ahead and take the third derivative. So here's the third derivative, and of course we're still assuming that f triple prime is equal to a triple prime. So the third derivative is 3/8 times x plus 1 to the negative 5/2. So there it is. Again, just as always, we're going to substitute our a for x. So there's our 0. And when we condense it down, it equals 3/8. Okay, so now we got a few terms and going here, and now we can kind of set it up as our series. Since we're dealing with polynomials, we can go ahead and denotate what we're doing as p. And see here how I have 3? This is because I took 3 derivatives. If I took a fourth or a fifth, this would be 4 or 5. So we're going to bring back up that format that I showed you earlier at the beginning. So this is our f of a, so we're going to substitute f of a here. This is our f prime, so we're going to substitute our f prime. This is double prime, so we're going to substitute our double prime. And this is our triple prime, so we're going to substitute our triple prime. And see, we're going to expand our factorials, so this would be 2 times 1, and this would be 3 times 2 times 1. And if we kept going, if we took a fourth derivative, it'd be over 4 factorials. It'd be 4 times 3 times 2 times 1. And the same thing with a fifth or a sixth if we just kept going in the trend. So now we have our big, long, ugly equation. Oops, I accidentally cut off the end of our equation here, so I'm going to... There you go. So here we've substituted our values. We've substituted x for this entire equation here, x plus 1. And we've gone ahead and we've expanded our factorials. So if we condense that down a little bit and subtract out our 0, we've got our trend as it continues through the series.